Hi friends, in this episode we are going to discuss about the last phase of post-production. After the mechanical and creative processes of editing is over, the director, the editor and the producer finally agree upon the final structure of the film. The film is now ready and the film is almost ready for delivery. We are now going to discuss how the image from the editing table reaches the color correction suites and finally is ready for the theaters. While editing, the rushes that are available for editing are all converted to proxy files. That is, files which are much lighter in size and thus are easier to work on. The raw files are much heavier in size and it's not possible for the editor and the computer to work with TBs and TBs of material. So in that case, it's far more easier to work with proxy files. Now if we look at a typical timeline where we have these few shots placed one after the other, let us consider this to be our final film. In this case, we are only placing 4 clips just as an example. A proxy file usually has got numbers burned on the image. If you see carefully, the first line indicates the name of the video file, which is a big name followed by the file extension. After that, we have the time code that is burned on the image, which actually belongs to the same video file. And we also have something called a frame number. So if we have recorded 2 seconds of a video, we should have 48 frames. Here we see this particular frame is at 320. This is the 320th frame of this video file. These images have burnt in numbers because it becomes easier for the editor to relink these files with the master files, because these are the references that are used for relinking. Once the timeline is ready, and this is the final timeline, we will export something called an EDL. The full form of the EDL is Edit Decision List. Let us export an EDL from this particular timeline. The EDL, and let's consider CMX3600, which is a Sony patented EDL format, and it opens on a wide variety of softwares. Since we do not have audio, I'll disable the audio and I will take an export. I'll save this as, say, EMMRC test and save it on the desktop. An EDL is used because a Final Cut Pro, this is the Final Cut Pro software, and a Final Cut Pro project will not open on other color grading softwares or any other software apart from Final Cut itself. So an EDL is an universal file that will open on any software that supports EDL or XMLs. I can also take an XML out if I want to. Let's see what this EDL actually looks like. Let's open this on a normal text editor. See, this is how the EDL will look like. If you look carefully, you will see that the EDL has got the clip name, the time code where the clip will start on the timeline, the time code where the clip will end on the timeline, and the duration of that particular shot, and also the time code on the timeline. So all these 3-4 information are placed on the EDL one after the other. Now if I import this EDL on any other software, this will translate this information and will exactly take the clip that is necessary for confirming. With this EDL, we can open the timeline, that is the selection of shots, on any other software. In this episode, as we are going to discuss about color correction, we will be opening this on a color grading software. There are a number of color grading softwares available in the market. DaVinci Resolve, Baselight, Scratch, these are all color graders. Color grading software is still a very expensive affair because it's not only the software, because DaVinci Light is available free. What matters is the projection that on which you are going to decide what colors are looking like. Projection system actually follows certain color spaces. In theaters, the color space that we see is called XYZ color space. On video, that is on HD video that we see on television, we follow a color space called Rec 709 or REC 709. The difference between these two color spaces is mainly that the gamut is much wider on the XYZ color space. That is, it's almost similar to what we can actually see. The variations of colors are much more on the XYZ platform, and that is the reason why this is followed on cinema, that is on theater projections. To have a projector which can display the XYZ color space, we need high-end equipment, and this is something that is not available on small computers or small setups. So color correction is actually an expensive affair because infrastructurally it is quite expensive. Let us now see how the EDL works on a DaVinci software. This is DaVinci Light, and on this we are first going to import all the raw files. These are the raw files placed one after the other that we have used in the film. See, here you won't see the burnt in image numbers. These are the heavy files that we were talking about. Now we are going to online the timeline that we saw on Final Cut. We will go to File, import the EDL that we had saved earlier. We called that test EMMRC. So let's import this file and open it here. This will automatically identify the clips that were used, and here you have the timeline that we actually saw on Final Cut Pro. This is a different software, a different timeline with the same clips placed one after the other. And these are raw files. Now if I play these raw files, this won't play properly because they are heavy files and it's not possible for a laptop to play back these files easily. For playing back these files and also for storage, we need hard drives which are striped, and even in certain cases we need servers. Striped hard drives actually multiplies the speed of the hard drives. So the access speed becomes higher. In that case, we can play back heavier files easily. But as I said, this all becomes expensive. So we need studios to do color correction. Now as we go through these files, we may find certain clips are not exactly similar to our mother timeline. In that case, the editor here goes through a process called conforming. Conforming is a process of matching the timeline that we have got on DaVinci with the reference video. This matching is done more or less manually because whatever automatic system we have followed so far is done by the EDL or the XML is over. In certain cases, there may be conflicts with the timecode, with the clip name, etc., which can be ignored by the software. But we cannot compromise on any shot and, so to say, on any frame. So every frame should match with the mother timeline. So in that case, in many cases, manually clips are taken from the media and placed on the timeline. This is called conforming. And after the conforming is over, the project is ready for grading. Now let us see how the basic color correction is done on DaVinci Resolve. We are not going to get into the details of this software, but generally how color correction is done on this software is what we are going to look at. On a typical color correction software, we usually have 4 rooms. First one is called the media room, where we get all the media files on a single bin. These are the files that were used in the film. Any other files, say for example the proxy files, are not taken into this bin. This prevents this timeline that we have created from having the proxy files on the timeline. So in the media pool here, we will only see the raw files that are our master files. On the edit room, we have our timelines. The EDL that we exported from FCP7 were imported on this timeline, and here we have it. This is our film. In this example, this is the film that we are going to consider. The first level of color correction happens at the correction level. That is, if a film is underexposed or overexposed, or the balance of the color is not right, that is taken care of. In this particular shot, if we want to correct the balance, we can do it, and for that we have to go to the color room. This is called the color room. These are the shots placed one after the other, and this is what we are going to correct. DaVinci Resolve follows a node-based color grading system, which means that filters are placed on every node. This is the first node, and if we want to add a node, we will click on nodes and add a serial node. This is our node. If we do certain changes here, let's just do something. Let's change the offset. We are going to discuss what this offset actually means later. After doing this correction, I need another node. So I add another node, and say for example, I give this a kind of a blue cast, and this is the effect that I get, say on the highlights and on the midtones. And I go on adding nodes, and I do something else. Say for example, I reduce the saturation of this particular shot. Now all these nodes put together gives me the effect of the correction. At any point of time, if I want to disable this, I will disable this node. This will bypass the node that I have in between and will give me the effect of all the other filters put together. If I want this node back, I'll click on Command D and I am back to my original image. So this is basically how color correction is done on this software. Since we are working with raw files, what we can do is we can directly change the raw information that is placed on the metadata with the file. Say for example, I want to change the exposure of the file, or if I had changed the exposure on camera, the effect that I would have got on the image can be achieved here on the metadata level. I have a camera raw setting here, and let's select this file, and I have an exposure setting. Now if I change this, this will affect the image directly. But this is not color correction. I am changing the metadata of the file. Since I do not have a codec in between, this immediately affects the image without hampering the image quality. I have a number of other settings which can also be changed on the camera raw. Let's get into the correction part of it. I have certain wheels here. There are two methods. One is called the primaries and the other one is called the log. On the primaries, the color wheels are divided into lift, gamma, gain and offset. On the log, it's divided into the shadow, midtones, highlights and offset. Let us open a vector scope to see how this actually affects the image. To see what is the difference that is happening in the image as we change the different parameters in the different color wheels, let us open the waveform monitor and the parade. Here on the waveform monitor we have a scale which starts from 0 and which ends at 1023. In many waveform scales, the scale starts from 0 and ends at 100. The 0 indicates the black level and the 100 indicates the white level. These levels should be maintained as we go on with the color correction process. If we judge this particular image here and we see the waveform, we'll see that it's mostly in the mid zone and it's not touching the black 0 mark. So, which means that this image does not have proper blacks in it and the image is concentrated on the mid zone. Now, if I just do a basic correction on this, let us do a basic correction, and if we see the effect on the waveform monitor, we'll see that the image is now spread from the highlights to the blacks. That is, now the image is properly corrected. On the parade monitor, we can see the individual separation of the R, G and the B. That is the red, green and the blue signals. Here, if we see the parade properly, we'll see that the blues are mostly on the black zone and the red is mostly on the mids and the highs. If you want a balance, we can balance the image with the color wheels. Here, if I want a balance here and I take the highlights, I'll reduce red from the highlights. So I'll push it towards blue, and on the shadow area I'll push it away from the red zone. See, as far as this parade is concerned, the image may look proper, but the image that we see here is not the image which is looking nice. The previous image was much better. So in that case, a decision has to be taken by the colorist. The vector scope, the parade, the waveform monitors shows you the technical qualities of an image, but what comes out finally is the aesthetic quality, and that should be decided by the director and the colorist. Let us talk about the offset tool. On the offset, if we change the values, you will see the entire graph is moving to the highlight zone or towards the black zone. The offset correction tool is given to take the graph without disturbing the proportions that are there between the highlights, mids and the blacks, and without disturbing the ratio between these three elements, we can push the graph towards the highlight zone or towards the shadow zone. This is the function of the offset correction. Generally, colorists usually start with the offset correction. On the primaries, if we see, we also have this offset, but the mids, the highlights and the shadows are here divided into the lift, gamma and the gain. It's more or less the same kind of correction, but it has got its unique features. We need a color grading software for color correction because there are certain features which are not available on editing softwares like Final Cut and Avid. Although these softwares also provide certain features for color correction. There are unique features on DaVinci which can be explored. Let's give you an example. Let's see this shot where I have the face of this woman, which is, according to me, is a little underlit. In this case, let us do the basic correction first. I add a node and I do the basic correction, and this is what I get after doing the basic correction. Now, if I want to selectively do correction on the face, I can do it, which is not possible in case of Final Cut Pro. I'll select a matte. I'll only select the face area and I will track it. This shot will take some time because it's rendering. These kind of shots where you have motion involved in the shot, in this case there is a slow track back. If you want to correct for a certain area within the frame which is moving, it's impossible for you to correct on Final Cut Pro because you can't selectively correct an image and also track it along with the movement of that character or that element within that image. So in that case, you need very specialized tracking mechanism which is available in softwares like these. Now, if you see the image properly, you will see that as the image track backs and the face becomes smaller and smaller, the mask that I have put on the image also becomes smaller with the face size. Okay, now the tracking is over. Now with this, I will do the correction that I want to do on this face. Say, I want to add a little red to this. So let me put a little red cast on this image. I'm just doing a drastic change to let you see the changes that is happening on the image. These are not aesthetically motivated. So if I want something like this, and I have already done the tracking. So let's see the image here. Let's come out of the mask and this is how it will look. Not only this, if I now play the video, it will track with the image. Now you can see the image is going backwards and it's also tracking. With these features in hand, you will be able to make your image look much better than what you have seen during shooting. This makes the film look better and much more appealing. After the color correction is over, we need to put titles, graphics and all these things on the timeline. Titles like credits are used for almost all films. To bring in title cards, we need to keep one thing in mind. The title should have its alpha channel on, which means that the title should be transparent. Here we have an example of a transparent title. This is a file which says EMMRC and the background is transparent. If I now bring this on a timeline and I place it on an image, see, the background is visible and only the text is placed on the image. If the background is not transparent, something like this is going to happen. This is an example of a file which has no transparency. That is, it is showing a white background. So the image will be covered by this title, although it has got the same text. So this is the only thing that should be kept in mind. When you are taking outputs for titles, it should be either TIFF or TGA or other formats which can have the alpha channel on. Once the timeline is ready, the image is ready for delivery. These images are then exported and taken to the final delivery station. When we are watching films on theaters, we essentially watch something called a DCP or Digital Cinema Package. The difference between DCP and a normal MOV file or a normal video file is that DCP is a package of video and audio material with certain other metadata which can be encrypted. You may be having the hard drive which contains the film of a latest release, but if you are not given the passcode, you won't be able to play that particular DCP. For this, you need the server for which the DCP is made, and you also need a password or a passcode which is called a KDM. This KDM is sent by the producers at the last moment, maybe a few hours before the projection should actually start. This device is done to prevent piracy and other malpractices. A DCP is made by specialized softwares, and once made, the DCP folder looks something like this. This is a DCP folder. Under this DCP, you have 6 files. You have an asset map, a CPL file, MXF file which contains the video, an MXF file which contains the audio, a PKL file, and a vol index or a volume index file. The MXF files use an encoding method which is called JPEG 2000 or J2K. This is the compression that DCPs use. So if we are shooting on RAW, you are grading your film on RAW, but finally when we see it on theaters, it's compressed, and it's using the compression called J2K. If we see the DCP folder properly, you will see that the first word here indicates the name of the film. After that, you have a short form which says whether it's a feature, it's a trailer, it's an advertisement, or a short film. In this case, we have a short film, so it's written SHR. Other information which are available is like this is in English, so it's written EN. It's 51, which means it has got 5.1 surround sound. It's 2K, which means it's shot on 2K. It may be shot on 4K, but the DCP is on 2K. Then we have the date, which is the creation date of this DCP. Then we have the code of the lab which prepared this DCP. In this case, it's written FLB, which means the film lab. And the final thing that is written on the DCP folder is OV, which means the original version. So if you look at the folder of a DCP, you can easily make out that these are the things that are present, or these are the features of the DCP. All these put together, we can go to the theater, give the hard drive, give the KDM or the passcode, and the film is ready for projection. There is a consortium called the DCI, or the Digital Cinema Initiatives, which are trying to standardize theaters and its projection system. SMPTE is a standardizing body which is trying hard to standardize all that is projected on commercial theater spaces. The DCPs which follow the SMPTE rules are called SMPTE DCPs. Previously, we were using interop DCPs. There are theaters which are e-cinemas. The theaters which use DCPs are called D-cinemas. But e-cinemas are finally getting out of the market, and what we are left with are D-cinemas. But it will take time in India to convert all the multiplexes and all the cinema halls to SMPTE standardized D-cinema projection system, because it's all about money and the economics of running a theater. With this, we are going to conclude the episode on color correction and different output methods.